Have you ever heard anyone say, "You are what you eat"? Is there any truth to that? Well, today we'll answer that question. And we'll hear the story of the scientists, their books, and the crazy experiments that led to our understanding of food, glorious food. In a hospital in the Dutch East Indies, patients began to develop a nerve disease that caused their muscles to become weak and some to become paralyzed. Scientists in the 1880s who were studying this disease were searching for a microorganism they assumed must be the cause of the disease called beriberi, but there was no microorganism. Then, in 1896, a scientist named Christian Eichmann noticed that some of the chickens that lived near the hospital also showed symptoms of beriberi. Many of the sick chickens died, but Eichmann studied the chickens that survived and learned that they were eating whole rice that still had their outer shell. He then learned that hospital food consisted of white polished rice in which the outer shells of the rice were removed. He found that whole rice reversed beriberi in both chickens and humans. Something that was present in the outer shell of the rice kernels cured the disease. This discovery, made over a century ago, provided the first clue that something missing from our foods can produce a disease. The fundamental components of the human diet are called macronutrients, and they include water, carbohydrates, fats, and protein, and they were recognized some 200 years ago. But even then, it was clear that some more elusive elements were needed to produce a fully healthy diet. No one knew exactly what these elements were, but in their absence, people were likely to develop a deficiency disease, like beriberi or scurvy. Most of the food we eat consists of water. For example, almost 95% of a tomato is water. Carbohydrates, proteins, and fats can be used by the body as a source of energy. These organic compounds can be broken down and used in chemical reactions that produce ATP and are a major part of our metabolism. Organisms use simple molecules to build more complex substances. For example, protein that we eat is broken down into amino acids, which are then used to build new proteins in an organism. So food provides our matter, what we're made of, and our energy, what keeps us alive. So in effect, we really are what we eat. We also need vitamins and minerals to allow for a wide variety of chemical reactions. Vitamins are simply organic chemicals, that is, from things that were once alive, like plants and animals, while minerals are inorganic and come from soil or water. And they must be in our food because we cannot manufacture them for ourselves. Vitamins are a surprisingly recent concept. A Polish emigre chemist in London by the name of Casimir Funk came up with the notion of vitamins, though he called them vita-amines, a contraction of vital and organic compounds. But Funk didn't discover vitamins, but merely speculated correctly as to their existence. But no one could produce the strange elements. Sir James Barr, the president of the British Medical Association, dismissed them as figments of the imagination. The discovery and later naming of vitamins didn't begin until almost the 1920s and has been a checkered affair, to say the least. In the beginning, vitamins were named in more or less strictly alphabetical order, A, B, C, D, and so on. But that system began to fall apart. Vitamin B was discovered not to be one vitamin, but several, and these were renamed B1, B2, B3, and so on, up to 12. And then it was decided that B vitamins weren't so diverse after all, and reclassified so that today we are left with 6 semi-sequential B vitamins: B1, B2, B3, B5, B6, and B12. Years after Eichmann's discovery, researchers found that rice shells contain vitamin B1, aka thiamine. Thiamine is a coenzyme needed for chemical reactions during cellular respiration. Without thiamine, the enzymes do not work and a basic function of our cells is disrupted. And so, although Funk determined the concept of vitamins and is often given credit for their discovery, many other people did most of the work. In fact, Sir Frederick Hopkins and Christian Eichmann were given the Nobel Prize for their work in 1929, a fact that left Funk permanently in one. It took a surprisingly long amount of time for people to take an active interest into what fills us and how it all works. Up until the Renaissance, human dissection was widely forbidden, and even after it was allowed, most people didn't have the, stomach for it.
A few intrepid souls, Leonardo da Vinci most famously, cut bodies up for the sake of knowledge, but even he noted that a rotting body was pretty disgusting. Specimens were nearly always hard to come by. In Britain, criminals hanged for murder were distributed to local medical schools for dissection, but there were never enough bodies to go around. Because of the shortages, a dark trade arose where bodies were stolen from graveyards. Many people lived in severe dread of having their bodies dug up and violated. A well-known case was the celebrated Irish giant named Charles Byrne. At 7 feet 7 inches, Byrne was the tallest man in Europe. His skeleton was wanted by the anatomist and collector John Hunter, and terrified of being dissected, Byrne arranged that his coffin would be taken out to sea. But Hunter managed to bribe the ship's captain, and Byrne's body was displayed at the Hunter Museum in the Royal College of Surgeons in London. However, in 2018, the museum was closed for refurbishment, and there has been talk of burying Byrne at sea. The rise of scholarly dissection coincided with the improvement in the standard of medical anatomical textbooks. The most influential anatomical work of the period, and indeed ever since, was Anatomy, the Descriptive and the Surgical, first published in 1858 in London and known ever since as Gray's Anatomy, after its author Henry Gray. Henry Gray was a rising demonstrator of anatomy at St. George's Hospital at Hyde Park Corner in London, when he decided to produce a definitive and modern anatomical guide. Gray was still only in his 20s, but began working on the book in 1855. For the illustrations, he commissioned a medical student at St. George's, Henry Van Dyke Carter, for payments of £150. Carter was painfully shy but highly gifted. All of his illustrations had to be drawn in reverse so that they would be printed the right way on paper, which must have been an almost unimaginable challenge. Carter did not only all 363 drawings, but all the preparatory dissections. As a collaborator, Gray was spectacularly petty. It is not clear whether he ever paid Carter in full or at all, and he certainly never shared royalties. He instructed the printers to reduce the size of Carter's name on the title page and to remove a reference to his qualifications to make him look like a regular illustrator, which is why it became known as Gray's Anatomy rather than Gray's and Carter's.
For a very long time, nearly everything we knew about the human stomach was thanks to an unfortunate accident in 1822. In December of that year, on Mackinac Island in Michigan, a customer was checking out a rifle in the general store when it accidentally went off. A young Canadian fur trapper named Alexis St. Martin had the misfortune of standing just 3 feet away and directly in the line of fire. The shot tore a hole in his lower chest and gave him something he really didn't want: the most famous stomach in history.
St. Martin miraculously survived, but the wound never entirely healed. His doctor, a U.S. Army surgeon named William Beaumont, realized that the inch-wide hole gave him an unusual window into the body's interior and direct access to the stomach. He took St. Martin into his home and looked after him with the understanding, sealed with a formal contract, that Beaumont would be free to perform experiments on his guest. For Beaumont, this was an incredible opportunity. In 1822, no one knew quite what happened to food once it disappeared down one's throat. St. Martin had the only stomach that could be studied directly. Beaumont's experiments consisted in suspending different foods on silk thread into St. Martin's stomach, leaving them there for a measured interval, then pulling them out to see what happened.
Sometimes, in the interest of science, Beaumont tasted the contents to test their tartness and acidity, and by so doing, he was able to determine that the main digestive agent of the stomach was hydrochloric acid. This was a breakthrough and caused great excitement in gastric circles and made Beaumont famous. St. Martin was not the most cooperative subject, and he often disappeared, once for 4 years, until Beaumont was able to track him down.
Despite their interruptions, Beaumont eventually published a book called Experiments and Observations on the Gastric Juice and Physiology of Digestion. What a mouthful. For about a century, medical knowledge of the process of digestion was thanks to St. Martin's stomach.
Ironically enough, St. Martin outlived Beaumont by 27 years. After drifting around for a bit, he moved back to his hometown of Quebec, married, had 6 children, and died at the ripe old age of 86, 60 years after his accident that made him and his stomach famous. The calorie is a strange and complicated measure of food. It's defined as the energy needed to heat 1 kilogram of water by 1 degree Celsius. But it's safe to say that no one ever thinks of it in those terms when deciding what foods to eat. Just how many calories you need is pretty much a personal matter. Until 1964, the official guidance from the United States was 3,200 calories per day for an active man. Today, that input has been reduced to 2,600 calories per day for an active man. Quite a big reduction.
The father of caloric measurement, indeed of our modern food science, was the American academic Wilbur Allen Atwater. On a trip to Germany, he was introduced to the exciting new concept of the calorie and returned to America with an urge to bring scientific rigor to the infant science of nutrition. Taking a position as professor of chemistry at Wesleyan University, he embarked on a series of experiments to test every aspect of food science.
Some of these experiments were a touch unorthodox, not to say risky. In one, he ate a poisoned fish to see what effect it would have on him. The effect? It nearly killed him.
His most celebrated project was the building of a contraption he called the respiratory calorimeter. This was a sealed chamber in which subjects were confined for up to 5 days, while Atwater and his helpers measured the various inputs and outputs to calculate caloric intake. The work was so exact that it took up to 60 people to read all the dials and perform the calculations. The president of Wesleyan University was mystified by the point of the calorimeter. The calorie was an entirely new concept after all, and especially the cost, and ordered Atwater to take a 50% pay cut. Atwater was undeterred and continued to work out the calories and nutritional values of practically all known foods. He published many books, including The Chemical Composition of American Food Materials, which remained the last word on nutrition for a generation. He was one of the most famous scientists of any type in America.
Much of what he concluded was ultimately wrong, but not really his fault. Nobody really understood the importance of vitamins and minerals or the importance of a balanced diet. Atwater thought that what made one food better than another was how well it served as fuel. He thought that fruits and vegetables, which gave less energy than other foods, should play no part in a person's diet. In 1904, Atwater suffered a massive stroke. He lingered for 3 years without recovering, and then died at age 63. But his efforts secured the calorie's place at the heart of nutritional science. It took a surprisingly long amount of time to learn that the things we eat can make you seriously unhealthy. The person most responsible for our enlightenment was a nutritionist from the University of Minnesota, Ansel Keys. Keys was born to a distinguished family in California, and he was a bright but unmotivated child. He dropped out of school at age 15 and got many exotic jobs, like a sailor in the Navy. Only then did he depart on his academic career. But he made up for lost time in a big way, acquiring degrees in biology, economics, oceanography, and physiology.
He settled at the University of Minnesota to become the founding director of its Laboratory of Physiological Hygiene. Keys rapidly became an expert on human nutrition. When America joined the Second World War, the War Department commissioned Keys to devise a lightweight food pack for paratroopers. The result was the imperishable army food known as K rations. The K stood for Keys. In 1944, as much of Europe faced the prospect of starvation because of the war, he embarked at what became known as the Minnesota Starvation Project. He recruited 36 healthy male volunteers and for 6 months allowed just 2 meals a day with a total intake of about 1,500 calories. Over the 6 months, the men's average weight dropped from 152 pounds to 115.
The experiment just showed what anyone could have guessed at the outset, that chronic hunger made the volunteers irritable, lethargic, and depressed, and made them more susceptible to illness. And when regular food amounts returned, they quickly recovered their lost weight.
On the basis of the study, Keys wrote a book called The Biology of Human Starvation, which was highly regarded but not particularly timely. By the time it came out in 1950, starvation was no longer an issue in most of Europe. Soon afterwards, Keys embarked on the study that would permanently seal his fame. The 7-country study compared the dietary habits and health outcomes of 12,000 men in 7 nations: Italy, Greece, the Netherlands, Yugoslavia, Finland, Japan, and the United States. Keys found a direct correlation between the levels of dietary fat and heart disease, a conclusion that is hardly surprising now, but then it was revolutionary. In 1957, with his wife Margaret, he produced a popular book called Eat Well and Stay Well, which promoted what we would now know as the Mediterranean diet.
This marked a milestone in nutritional science. Up until this point, almost all the efforts were directed at combating deficiency diseases. But now people learned that too much nutrition could be as dangerous as too little. We may think of nutrition as just what goes in, but it's also what comes out. The first person in modern times to take a close scientific interest in that was Theodore Escherich. Escherich was a young pediatric researcher who began to examine baby stools in the late 19th century. He found 19 different microorganisms in there, which was a lot more than he expected to find, because the only obvious source of input was their mother's milk and the air they breathe.
The most abundant of these microbes was called Escherichia coli in his honor. E. coli has become the most studied microbe on the planet. It has spawned literally hundreds of thousands of papers. E. coli is necessary for our digestion by producing vitamin K, but a mutation of it is harmful, hospitalizing over 2,000 people a year in the US. Equally pernicious is salmonella, which has been called the most ubiquitous pathogen in nature. According to a USDA study, about a quarter of the chicken sold in stores are contaminated with salmonella. 40,000 cases of salmonella infection are reported in the United States each year, and by one estimate, for every reported case, a further 28 go unreported. That works out to over 1 million cases each year. Salmonella has nothing to do with spawning fish. It is named for Daniel Elmer Salmon, a U.S. Department of Agriculture scientist, though it was actually discovered by his assistant, Theobald Smith, yet another one of those forgotten heroes of medical history. Smith was able to isolate salmonella in 1885, long before any other American could do so.
Daniel Salmon was the head of the bureau at the U.S. Department of Agriculture, and the convention of the day was to list the head of the department as the lead author on the paper, and so that's how the name got attached to the microbe.
Besides the nutrients we mentioned, it is also recommended that a person's diet include foods high in fiber, aka roughage. Fiber is what makes up the tough walls that surround plant cells and cannot be broken down in our digestive system. Why then do we need it? Because it cannot be digested, fiber must be eliminated by the body, which keeps the digestive system moving.
The organs that make up the digestive system have many muscles, like your arms and your legs, and they also need to be kept in good shape. Fiber helps those muscles work out by forcing them to remove it. As a result, fiber helps remove dangerous substances or toxins that may be present in the food, like the ones we mentioned. And so eating foods with a sufficient amount of fiber is an important part of maintaining good health. So there you have it, the stories of the experiments that changed our way of looking at food. If you've learned something you didn't know before, be sure to leave a comment as to what that was and what you'd like to see next.